Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share our videos and also subscribe if you have not subscribed before. Make sure you press on your subscribe button. Presently, we have over 250 videos on our platform, on our channel already. It means you can come here and learn any topic of your choice without any problem. Anyone you are expecting to be there and is not there yet, you can leave a comment below or you reach us with this line. With this line, you can do three things with it. The first one, you can call us, you can WhatsApp us, and lastly, you can Telegram via Telegram. All this allowed, either of the three. Okay, what I have for you here is the Electromotive Force, which I'll be on electricity anyway. I'm on electricity, which is under physics. In this platform, you can learn math, physics, chemistry. Anyone you want to learn, you are good to go. Now, Electromotive Force, the outline of this video. The first one is definition of electromotive force. The second one is internal resistance and terminal potential difference, loss of volts, and example on them. This example is possible on our next video to give more examples because it's a much one, But by the end of this video, you will understand all this. You will understand all this. Now let's start. You all know what is the electromotive force, and okay. Let's start from here. Now, when we talk about electromotive force, what are we talking about? The electromotive force I told you earlier that we always use EMF to denote it, which I was referring to that, which is our last video. I was using something like this, EMF to denote it, which is capital letter E of a, I would like to cut my body to 2, of a cell is defined as the total work, done in driving one now of electricity round a circuit. That is what electromotive force is talking about. That is what electromotive force is talking about. Now, and let me add more to this thing. The electromotive force of a cell is also defined as the potential difference between the terminals of a cell when it is an open circuit. That is to say, not to an Now, okay, that is what we need to know about electromotive force. I think my handwriting is more legible. If it is not, please, I'm expecting to leave a comment so that it will be of help to me. Okay, and with this, you can see I've mentioned the one of self and also the electromotive force of himself, which you need to understand those things very well. Now, when we talk about internal resistance, now I was explaining something on internal resistance in our previous video, which is I was explaining something on a resistor and resistance. Now we can have resistors, and when you have accumulated of resistors, generate resistance. Please take note of that. Don't be confused of resistance and resistors. Now, okay, now let me quickly explain the internal, which is the second outline, the internal resistance. The resistance, which is always on small letter r, is always denoted by what? Small letter r. Now, external resistance is denoted by what? Capital letter R. Please take note of that. This is denoted by what? Small letter r. Now, internal resistance of a cell is the to the current flow when it is discharged. When it's discharging, let me use the word discharging. Discharging current to a circuit. Okay, that is what we need to know about that. That is internal resistance of a cell is the opposition to current flow. Now, when we talk about, I've explained what is called resistance, internal resistance, and external resistance. Now, the last thing we need to understand here also is what is called terminal potential difference. Now, how can I use this part? Oh, this is very small. I need to cut the board very well. I need to please take note of this information because our class will be resting upon it anyway. So when we reach the calculation part of it, we'll get it right. Now, the next thing I want to talk about is terminal potential difference. I've told you earlier that our potential difference is always called voltage, which is we have V to denote it. This is V, not U. Sorry, don't mind my writing. V. Okay, to denote it. Now, when we talk about potential difference, is defined. Is defined. Let me quickly use the whole board as the potential difference. Sorry, please, potential difference between the terminal of a cell when is delivering current to an external resistance, which is my R. I've told you that we have internal and we have external. Okay, which is very, very important. The last part of it, which is we will be talking about the loss of volts, which is the loss of volts or voltage. Anyhow, which is, we call it V, is the potential difference across the internal resistance. Now, it means what you are trying to say here is my E equals to V plus small v. This is big V, this is small v. And okay, before we talk about that, resistance R. Okay, before we talk about this, let me quickly explain something. Something is missing out. Resistance R, which is small r, of a cell. This statement is not correct. Of a cell. Now, we have told that electromotive force is equals to potential difference across external resistance plus potential difference across internal resistance. Okay, that is very, very important. It means I cannot write out the message, the what I wrote earlier, that electromotive force, which I told you is always denoted by E now it will be equals to big V, which is external. This external is big V and plus small v. Now, I've told you from our Ohm's law. Let's apply Ohm's law here now, which is Ohm's law let us to know what is on ground. By Ohm's law, let us to know that my V equals to IR. If it is small v, small v will now be equals to I of small r. Please take note of that. This is Ohm's law, which what I'm applying now. It means I can say that what my E, electromotive force, equals to I big R plus what I small r, which I can also rewrite it by having I. I is a current which is caused, is present here, which is normally in mathematics. Dr. Dollar Entertainment. Oh, sorry for the break in transmission. It means I can now continue by having I of big R plus small r. What did I do? I just factor out the I, which is known as current. Now, with what is on ground, I can rewrite by having my I can also be equals to E, which is electromotive force all over R plus small r, which I've explained that earlier in our previous video. Okay, I can call this one equation 2. I can call this one equation 1. Please take note of that. I can call this one equation 2 and I call that one equation 1. Now, with this, I think I've explained all you need to know on the first one, terminal potential difference, also internal resistance, and electromotive force on itself. Okay, now let me try to give more examples if time permits me, as many as I can. But I would love to give more examples on our next video, which is now application of the question of this part, because it's a part that you need to understand when it comes to electricity under physics. Now, example: a battery of electromotive force 24 volts and internal resistance 4 ohm is connected is connected to a resistor of 32 ohms, what is the terminal potential difference of the battery? Now, I have this particular problem to work on, which you can be given anywhere. Now, it's a very simple one, but how do I solve it? Let's go. Solution. Now, whether you are asked to draw your circuit or not, it's advisable to start solving your problem by drawing your circuit. Very, very important. Please take note of that. When you are working on a circuit like this on electricity, make sure, try as much as possible to draw out your circuit. It will refresh you more mark, and it will enlighten you more on what you have to do. Anyway, now what is there is that the first thing I will do, I'll be happy to draw my circuit. Now it means my circuit will be like this. We have a volt. Okay. Okay, this is all known as current. Anyway, now it means my volt, electromotive force of 24 volts. It means my E equals to 24 volts. That is very important. My internal resistor, which is my R, is 4 ohms. What else can we talk about? And is connected to a resistor of what? 32. That is all. By so doing this, you will know what you are doing and know where you are coming from and where you are going. Now, with this, I can now continue that. Now, I want to find, firstly, find I, which is I is known as current. It's known as current. Now, it means I will have my I equals to all over what? R plus small r. R plus small r. We all know what my R is and my small r is. But you don't know what is. Now, we all know what my R is and my small r is. Now, with what I've done here, I've interpreted. It means my small, this is my big R and this is my small r. It means I can continue by having 24 divided by what is my big R? 32 plus what? 4, which I'll be having my I 24 divided by 36. Now, which I'll be having it's also the same thing as 2 all over 6 ampere, which also is known as my current. In your calculator, we print it as 0.67 ampere. Now, since that, from there, I can now continue by having my terminal, which is what is the terminal potential difference? Now, we all know that terminal potential difference, we all call it, it means I'll be talking about big V. My big V, which is terminal potential difference, will be called big V, which is equals to I of big R. I of big R. Now, because it's terminal, I've told you earlier, which is big R, with help of our Ohm's law. Now, it means I'll be having my V equals to, what is my high? My high is what stays, and my big R is 32, which is 0.67 multiplied by what? 32. It will be advisable for you if you don't know how to hold onto, don't know how to deal with what's the name of this thing? Decimal. You move it this way. It will be very simple and easy to get rid of here. Which anyhow you will do is, it means terminal potential difference will be 21.3 volts. That is all. Make sure you put the unit. It's very, very important. Now, 21.3 volts, which is simple and straightforward enough. Now, let me show one more example before I give example, and also give more application of this part. Okay. Now, let me move on to problem like a cell of electromotive force, which is a 15 volts, is connected in series with a resistor of resistance 3 ohms, a high resistance volt meter connected across the cell, registered 0.9 volts. Calculate the internal resistance of the cell. That is what I'm talking about. I've told you earlier, you are asked or not you are asked. Make sure you start with your what? Your circuit. It means advisable to draw your what? Your circuit out. It means I have something like this, 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 I have something like this. Now there will be a vote. Now it means I'll be talking about my E of 15. 1.5. This is 1.5 volts, and my small r will be I don't know it. Let me call it question mark. Now connected with something. With this connection, this is the connection here, which is, I'll call it V, which is of 0.9 volts. Now with this, I've seen, you can see that the question is half solved. The resistance is what? Now, which is very, very important. If I want to do it, I can say my is 1.5 volts. Voltage is 9 volts, and my R is what? 3 ohms, which my small r, I don't know it, question mark. By so doing this, I can now say that what? Current flowing in the circuit will be equals to I equals to E all over big R plus I. Now, which I'll be having 1.5 divided by 3 plus small r. Now, with this, you can see that I'll be having this one funny equation. Now, let me leave it like this. It means I've got my high equals to 1.5 divided by 3 plus, which you can cross multiply anyhow you want to do it, but 2 unknown are there. Now, I will now move on to by saying potential difference across potential difference across cell. Now, across the cell, which is my V, will be equals to E minus. Now, it means across the cell, we'll be having something like what? Like that. Now, we all know what our V is saying. It means I'll be having my V equals to, what is my E? My E is 1.5 minus 0.9, which I'll have it as a 0.6 volts. Now, since I have it, and from our Ohm's law, my Ohm's law small v equals to of this, which is current multiplied by the internal resistance, which is that. Now, we want to know what our V is. 0.6 equals to IR. 0.6 equals to what? IR. Now, can I substitute this into this? Can I substitute that into that? It means from here, my R will be equals to 0.6 divided by what? I. My R will be 0.6 divided by what? R. Yes. Okay, 0.6. Yes, my high, sorry, let me make my high. My I will be, make my I will be equals to 0.6 divided by what? R. Now, anyhow you want to do it, which I can now say that what? Substitute I into, substitute this 1.5 divided by 3 plus R. 1.5 divided by what? 3 plus R. Which I can, anyhow you want to do it. Now you are looking for it towards the what? It means to, we are obtaining 1.5 divided by 3 plus small r multiplied by r equals to 0.6. What did I do there? I've successfully cross multiply and move on with what I need. Now I can now move on by having 1.5 r equals to 0.6 bracket of 3 plus r, which I just cross multiply. Since I have it that way, I can now move on by having what x? I'll be having 1.5 r equals to, this one will be 1.8 plus 0.6 r, which I collect like times, which by collecting like time 1.5 r minus 0.6 r equals to 1.8. Now by so doing this, I'll be having 0.9 r equals to 1.8, which my r will be my r will now be equals to, which is my internal resistance, will be 1.8 divided by 0.9, which the same thing as what? 2 ohms. My answer is what? 2 ohms. That is all. That is what? All. Okay, you can see, I think I won't go beyond this. In our next video, I'll be working on efficiency of a cell. You know, I'll give example on efficiency of a cell, and I think I'll be mentioning efficiency right from our what's the name of this thing? Okay, now don't forget that you are on with Further Solutions Academy. Don't forget that you are with being hosted by Further Solutions Academy, where learning is being simple. Further Solutions Academy. I encourage us to share, and if you have not subscribed, make sure you subscribe immediately before, because we have more than enough for you in this platform. If you have any comments or you are expecting any topic that is not yet available, also you are free to leave a comment below, which is you can leave a comment below, which is email us, or you contact us with this line. You contact us with this line. For your information, you can do 3 things while this line is on. The first thing, you can call us. The second thing, you can WhatsApp us. And the last thing, you can Telegram us. These are the 3 things that can happen with the number. Once again, thanks for watching.